Namaste, students. I am Dr. Amita Kapoor. Have you ever stopped to think about what connects the profound wisdom of our ancient rishis with the powerful computers we use every single day? Well, it's a beautifully simple idea: the art of classification. For thousands of years, our ancestors would look up at this vast dark sky, but they didn't just see a random spray of lights. No, they saw patterns. They grouped stars into constellations, which helped them tell stories and even navigate the world. Just think about the Saptarishi, the seven great sages. Their story is written in the stars. This very act, this finding patterns and grouping things together, that's a simple yet incredibly powerful form of classification. And this skill, this art of grouping things, it's not just for stargazing. It's a fundamental human tradition, something we've always done to make sense of the world around us. Our ancestors were absolute masters of classification. I mean, think about it. Ayurvedic scholars would carefully group herbs based on their healing properties. Farmers knew exactly how to classify different grains to get the best harvest. And even in our own kitchens today, we group our spices by taste and how we use them. Our ancestors used their senses, features like shape, smell, texture, to decide what belonged with what. So, what does this all boil down to? Well, classification is really just the process of sorting things. It's about putting things into categories based on what makes them similar, based on their shared features. It's how we create order out of what might seem like chaos. Okay, so how do we teach this very human skill to a machine? Well, while you and I use our senses, a computer sees the world in a totally different way. For a computer, everything, and I mean everything, is understood through the language of numbers and measurements. Let's dig into that a little deeper. How does a computer actually turn something from nature into numbers? We're going to use a really famous example from biology to understand this: the iris flower. So, a computer doesn't see the beautiful purple color or the delicate shape of this flower, not at all. Instead, it sees data. It can measure with amazing precision the flower's features, things like how long its petals are or how wide they are. These measurements become the computer's way of seeing. And all those measurements, taken from 150 different iris flowers, they get stored in a table that looks something like this. You can think of it like a spreadsheet. Every row is one flower, and the columns are its features, its measurements. This is exactly how the physical world of a flower gets translated into data that a computer can actually understand and work with. And this is where it gets really interesting. When we take all those numbers, the petal length and the petal width for all 150 flowers, and we plot them on a simple graph, well, something kind of magical appears. You see, the points aren't just scattered everywhere. They naturally form these distinct groups, or what we call clusters. It turns out each of these clusters represents a different species of iris. You can literally see it with your own eyes. The points that are huddled close together on the graph belong to flowers that are similar in the real world. This visual clustering, this is the first step in how a computer starts to see and understand the different types of flowers. So we can see these groups, which is great, but how does this help us classify a brand new flower? The answer is in a really simple rule: finding the closest neighbor. Okay, imagine we're walking in a field and we find a new iris flower. We measure its petals. The big question is, which of the three species is it? Now, to answer this, a computer needs a clear, logical rule. It can't just guess. And it finds that rule in a simple, really elegant idea from mathematics. Does this look familiar? It should. It's the distance formula from your geometry class. This formula gives us a super precise way to calculate the straight line distance between any 2 points on our graph. It basically turns that visual idea of closeness into a solid number that the computer can use. So the method itself is beautifully simple. First, we take our new unknown flower and we plot it on the graph. Second, we use that distance formula to calculate its distance to every single one of the other 150 flowers. And third, we just find the one known flower that is closest to our new one, and we say, okay, our new flower must belong to the same species. And look at this. The new flower is that black dot. Right away, our eyes tell us it probably belongs with the green group. But a computer doesn't guess. It calculates all the distances and finds that yes, its single nearest neighbor is, in fact, one of the green dots. The math confirms what our eyes were telling us. This elegant technique has a name. It's called nearest neighbor classification. Just by finding the single closest point in all of our data, we can make a really smart data-driven prediction about what our new flower is. It's so simple, but it's incredibly powerful. So let's zoom out for a second. This is about so much more than just sorting flowers. This simple idea is actually a powerful building block of intelligence itself. This technique, this whole idea of measuring how similar things are by measuring their distance, it's a fundamental building block in the world of data science and even artificial intelligence. The very same logic is used in much, much more complex systems all around us. Our journey today, all the way from the ancient rishis charting the Saptarishi to an algorithm classifying a flower, it shows us something really profound. This quest to find patterns and create order is a timeless human thing. So, the question I have for you is, where else do you see this powerful idea at work in your own life? Think about it. Namaste.